Please subscribe and you can download this code from description below. Title: Why Python's requests is faster than C's libcurl, a comparative analysis. Introduction. Python's requests library and C's libcurl are both popular choices for making HTTP requests. However, it may come as a surprise that requests in Python can be significantly faster than libcurl in C for some use cases. In this tutorial, we'll explore why Python's requests library is often 10 times faster than C's libcurl and provide code examples to illustrate the differences. Table of Contents. HTTP Request Basics. GIL, Global Interpreter Lock. Simplicity versus complexity. Code examples. 4.1 Python requests example. 4.2 C libcurl example. Benchmarks. Conclusion. HTTP request basics. Before diving into the performance comparison, it's essential to understand the basics of HTTP requests. Both requests in Python and libcurl in C serve the same fundamental purpose, sending and receiving HTTP requests. They both offer a wide range of features for making HTTP requests, such as handling various HTTP methods, get, post, put, delete, managing cookies, handling redirects, and more. GIL, Global Interpreter Lock. One of the key reasons why requests in Python can outperform libcurl in certain scenarios is the Global Interpreter Lock, GIL. The GIL is a mutex that allows only one thread to execute in the Python interpreter at a time. This means that Python cannot take full advantage of multi-core processors, which may slow down CPU-bound tasks. However, when making HTTP requests, the GIL can be beneficial. HTTP requests often involve waiting for I/O, example waiting for a response from a server, during which Python can yield control to other threads, resulting in improved concurrency. Simplicity versus complexity. Requests in Python is designed to be user-friendly and straightforward, making it easy for developers to make HTTP requests. It abstracts many of the low-level details of networking, allowing developers to focus on their application's logic. In contrast, libcurl in C offers more low-level control, enabling developers to fine-tune every aspect of the request. However, this complexity can sometimes lead to inefficiencies, especially if not used optimally. Code examples. 4.1 Python requests example. Here's a simple example of making an HTTP GET request using Python's requests library. 4.2 C libcurl example. Here's a comparable example using C's libcurl. Benchmarks. Benchmarking the performance of requests in Python and libcurl in C can be highly dependent on various factors, including the specific use case, system resources, and network conditions. In some cases, Python's requests may perform significantly better due to the factors mentioned earlier, like the GIL and simplicity. However, for extremely high-performance scenarios, fine-tuning libcurl in C might be the better choice. Conclusion. In most practical scenarios, Python's requests library offers a simple and efficient way to make HTTP requests. The Global Interpreter Lock, GIL, can sometimes work in its favor when waiting for I/O. While it may not always be 10 times faster than C's libcurl, it's a reliable and convenient choice for many developers. For specialized and performance-critical tasks, libcurl in C can be a viable option, allowing you to fine-tune every detail of your HTTP requests. ChatGPT. Python's requests library and C's libcurl are both popular tools for making HTTP requests, but the apparent speed difference might seem counterintuitive given C's reputation for speed. However, the perception of speed can often be influenced by various factors like ease of use, implementation details, and the environment in which the code runs. Let's explore why Python's requests can sometimes perform comparably or even faster than C's libcurl. Firstly, it's important to understand that Python is an interpreted language, meaning it's typically slower than lower-level languages like C, which are compiled directly into machine code. However, libraries like requests can be optimized in various ways that make them surprisingly efficient. One of the reasons for the seemingly faster performance of requests compared to libcurl in some scenarios includes: under the hood, requests uses urlib3, which itself uses http.client, a Python standard library module. http.client in turn has C extensions that interact with the operating system's networking capabilities. This means that even though you're using Python, a significant part of the heavy lifting for network operations is done in compiled C code, providing efficient network interaction. Python abstracts away a lot of low-level complexities that programmers deal with in C. While this can make Python code slower, it also provides a more straightforward, high-level interface for making HTTP requests, reducing the time and effort needed to write code. In contrast, using libcurl in C involves working at a lower level and managing more details, which might make it seem faster but requires more effort to achieve similar results. Here's an example showcasing a simple GET request in both requests and libcurl. In both cases, the code is relatively simple. However, the Python code is more straightforward and readable due to its high-level abstraction. The performance differences between the two might vary based on multiple factors such as system load, network conditions, and the specific use case. C's libcurl offers more control and customization but comes with a steeper learning curve compared to the user-friendly interface of Python's requests. Remember, the perception of speed can be influenced by various factors, and the choice between requests and libcurl should consider not only performance but also the ease of use, maintainability, and specific requirements of the project. ChatGPT